Okay, today we're going to see about driving the OLED display. Very simply, just trying to print one letter on the display and try to explore and see how it's done through the ASF libraries. And I'm going to be using the 384, the Xmega 384C3 microcontroller on my demo board. So start a new project, and we're going to do an ASF board project. And this will basically load up a bunch of well, actually ask for our choice of microcontrollers. You can narrow it down by going to Xmega. I gotta try to find it. There it is, 384C3. And we use the Xmega C3 explained board template. And then we still have to go into ASF and add a bunch of the peripheral libraries. We're trying to keep it to an absolute minimum. Use the wizard and we'll go through the list here. So in our list you can see we've got a real basic already set up. These modules already set up. Basically the ports that we covered in the other lessons are set up. Generic board support. But for the to drive the LED display, we're going to need it's called the GFX library. There's a bunch of different ones for like color graphics, color system font service. We want a font service, monochrome font service. Highlight it and we can add it to the right column, and then apply. And then an ASF Explorer, you can see we've got it listed here. See if we can find a quick start guide. Just kind of jump start our exploration. And see, they've got a real basic example, which is good, where you initiate, the board's initiated, then you initiate the source clock, then the initiate basically the LED display, and then a simple command to draw a line starting at a X and Y coordinate, X and Y coordinates on the display, and then the I think this is the pixel, whether the pixel is lit up or it's dark. But in order to let's go over some basics, because the LED that's on the demo board, and it's also used in some of the Adafruit displays. And it's fairly common, but the chip that drives it's the SSD 1306, and that's where where kind of like the heart, the guts of the display, what controls all the pixels on the display. And the important part about this little display is it's divided up into 8 pages. They call them pages, numbered 0 through 7. Each page is basically a column, vertical column of 8 pixels. And by writing a byte, like it says here, when one data byte is written to the GD-RAM, all the rows image data of that same page of the current column are filled. In other words, the whole column 8 bits pointed by the column address pointer is filled. In other words, when you initiate the board, when you initiate the display, you'll have an initialization function, and we'll go through that too, but it's basically it's going to set up all the parameters for the display, how bright you want it. Are you going to start from the top to the bottom or bottom to the top? It's highly customizable, but we keep everything as simple as possible. But when the display starts out, the pointer will be pointing to one of these columns, however you initialize it, will be pointing to where you tell it to start. And say we started at page 0, and we wanted to light this pixel up in the top corner here, we would start at page 0 and in our initialization function, and then send it write a byte to it through the SPI or USART, and then it'll write the byte in a vertical column, lighten the pixels up. If we send it the 0 hex byte, then it won't light any of the pixels up. And we send it 0 hex FF, it'll light all of them up. So just depending on what byte we send, we can customize how many pixels are lit on each vertical column. So after you send a byte, then the pointer will move to the next column. You send another byte, it'll light this column up, and then automatically the pointer advance to the next column, etc. And then this way you can form your primitive shapes, or in our case, your fonts. Right. One thing I forgot to mention when we brought the GFX monochrome library from this side to the right side, don't forget to pick the display here. In this case, our case UG 283 2H-SWG04. Make sure that is chosen and then apply it. That's going to add a whole bunch more of the libraries to run the display. And part 2, I'll start digging down into the nitty-gritty of the library and see if we can print out a single letter. It's going to be hard, but we can do it.